talking about improving TTI and reducing memory usage and size of your app by adjusting ProGuard rules to your project. You are not enabling ProGuard for release builds and creating APK with code for all CPU architecture. You ship a larger APK at the beginning of each React Native project. You usually don't care about the application size. After all, it's hard to make such predictions so early in the process, but it takes only a few additional dependency for the application to go from a standard 5 MB to 10, 20 or even 50 depending on the code base. Should you really care about the app size in the era of super fast mobile internet and Wi-Fi access everywhere? Why does a bundle size grow so rapidly? We will answer those questions in this section, but first have a look at uh, what a typical React Native bundle is made up of. By default, a React Native application on Android consists of four sets of binaries compiled for different CPU architecture: a directory which with resources such as images, fonts, etc., a JavaScript bundle with business logic and your React components and other files. React Native offers some optimization that allow you to improve the structure of the bundle and its overall size, but they are disabled by default if you are not using them effectively, especially when your application grows. You are unnecessarily increasing the overall size of your application in bytes. They can have a negative impact on the experience of your end user. We will discuss it in next session. Bigger APK size means more time needing to download apps from the app store, more bytecodes to load into the memory. It's great that you and your team operate on the latest devices and have fast and stable access to the internet, but you need to remember that not everyone has the same luxury. They are still part of the world where network accessibility and reliability are far from perfect. Projects such as Starlink already improved that situation, but that will take time to cover the most remote areas out there. Right now there are still markets where every megabyte of traffic has its price. In those regions, the application size directly impacts the conversion, and the installation and cancellation ratios increases along with app size. It's a common belief that every well crafted and carefully designed application not only provides a beautiful interface uh, but is also optimized for the end device. Well, that is not always the case, and because the Android market is so competitive, there is a big chance that a smaller alternative to those beautiful yet large apps is already gaining more traction from the community. Another important factor is device fragmentation. The Android market is very diverse in that respect. There are more than 20 popular manufacturers, each releasing an array of devices every year, contributing to a large, relatively significant share of mid to low end devices, which account for over 60% of all smartphone sales annually. And those devices may face issues when dealing with bigger APKs. As we have stressed already, the startup time of your application is essential. The more code the device has to execute while opening up your code, the more longer it takes to launch the app and make it ready for the final interaction. Now let's move to the last factor worth mentioning in this context: device storage. Apps usually end up taking more space after the installation. Sometimes they may not even fit in the device memories. In such a situation, user may decide to skip installing your product if that would mean removing other resources such as applications or images. Solution: flip the boolean flag, enable ProGuard in release build to true. Adjust the ProGuard rules to your need and test release build for crashes. Also flip enable separate build per CPU architecture to true. Android is an operating system that runs on plenty of devices with different architectures, so you build must support most of them. React Native supports for while developing your application. Gradle builds the APK file that can be installed on any of the mentioned CPU architecture. In other words, your APK, the file outputted from the build process, is actually four separate applications packaged into a single file with .apk extension. This makes testing easier as the application can be distributed onto many different testing devices and at once. Unfortunately, this approach has its drawback. The overall size of the application is now much bigger, but then it should be, as it contains files required by all the architecture. As a result, users will end up downloading extraneous code that is not even compatible with their phone. Fully, you can optimize the distribution process by taking advantage of app bundles when releasing a production version of your app. App bundle is a publishing format that allows you to contain all compiled codes and resources. It's all due to the fact that Google Play Store Dynamic Delivery will later build tailored APKs depending on the end user's device. To build app bundle, you have to simply invoke a different script than usual. Instead of building Gradle assemble release. Use Gradle bundle release as presented here. The main advantage of the Android app bundle over builds for multiple architecture per CPU is the ease of delivery. After all, you have to ship only one artifact, and dynamic delivery will do all the magic for you. It also gives you more flexibility on supported platform. You don't have to worry about which CPU architecture your end user's device has. The average size reduction for an app is around 35%, but in some cases it can even cut in half according to the Android team. Now, another way of decreasing the bundle size is enabling ProCard. ProCard works in a similar way to dead code elimination from JavaScript. It gets rid of the unused code from third-party SDKs and minifies the code base. However, ProCard may not work out of the box with some projects and usually require an additional step to achieve optimal design. In this example, we are able to reduce the size of the mentioned 28 MB build by 700 KB. It is not much, but it is still an improvement. Another good practice is keeping an eye on resource optimization. Each application contains some SVG or PNG graphic that can be optimized using free web tools. Reducing redundant text from SVG and compressing PNG's images can save some bytes when your project has already too many of them. A smaller APK, slightly faster TT, and slightly less memory used. All the mentioned steps are worth taking when you're struggling with a growing application size. You will achieve the most significant size reduction by building the app for different architecture, but the list of possible optimization doesn't stop there. By striving for a smaller APK size, you will do your best to reduce the download cancellation rate. Also, your customers will benefit from a shorter time to interactive and be more inclined to use the app more often. Finally, you will demonstrate that you care about every user, not only those with top-notch devices and faster internet connection. The bigger your platform gets, the more important it is to support those minor groups, as every percent of user translates into hundreds of thousands of actual users. If you like to learn more about optimizing Android, check the Android profiling chapter. Experiment with the new architecture of React Native. So yeah, we will see this in the next video. Thank you for watching. Bye.